Alright, welcome to your Chapter 9 review. This is all about rocks and soil. Okay, we're going to start by defining weathering. Weathering is just the breakdown of rocks into smaller pieces, into sediment. There are two subtypes of weathering, though, that we're going to talk about. The first is mechanical weathering. In mechanical weathering, you have the breakdown of rocks by physical means. So physical means is the key point there. Mechanical weathering, you have physical means. There are several different types of mechanical weathering. I'm going to briefly describe each of those. The first is ice wedging. Ice wedging, you have, say, a rock that has a little bit of a crack in it, and overnight, or during the day, some water seeps into that crack. And then overnight, same rock, same little crack. Overnight it gets really, really cold, and that ice freezes. And ice, or water when it freezes, expands. As you know, if you've ever put like a water bottle in the freezer, and then the lid's popped off, or the bottles become a funny shape afterwards. Water expands when it freezes. It actually expands 9%. And so that causes the rock to move apart. So literally ice is wedging in the crack and causing the rock to get, the crack in the rock to get bigger. Over time, as ice wedging happens again and again, you're going to get the rock breaking in two. Alright, the second type of mechanical weathering is abrasion. Now we've talked a lot about abrasion during class. That's like, think of abrasive actions or abrasive words, or the ones that kind of rub you the wrong way. So abrasion of rocks, you have rocks that are rubbing against one another. And the rocks are going to be smoothed out because of this. If you had a square rock, and as it rubs with another rock, this corner is going to get smoothed out, and this corner will get smoothed out. So they'll go from being a square rock, it's going to become more of a circular rock. These corners just going to get smoothed a little bit as abrasion happens. Okay. So you just have the corners, the sides of your rock, smoothing out. So an example of a place where abrasion happens would be in, say, a creek bed. You get the rounding of rocks because water is working against to move the rocks, and the water is acting as an abrasive force against the rocks. You could also look at like a seashore, the ocean. You have, see the little pebbles, what were probably sharp rocks are rounded out. Or you could think of like sea glass. You might have a bottle that gets into the ocean, it gets thrashed around by the waves, it breaks into smaller pieces, and as the waves, and as the water rubs against the glass, it gets smoothed out, and so you get sea glass that's those really pretty little pieces, colored pieces of glass that are rounded, and the edges are no longer sharp. So that's abrasion. So you have, could have water rubbing against the rocks. You could have rocks rubbing against each other. Another example would be the wind blowing sand. If sand is being blown at, say you have a big rock out in the desert and you have wind coming at it, and it's carrying some sand with it, It can actually, and you get really cool formations, like maybe in Utah. We saw some pictures in class we looked at of Utah that had really cool red rock formations that had like holes in them in the middle of these big tall rocks, because these sand particles are being blown in against the rock on the wind and causing the rocks to be weathered. You could also have gravity as a force that's abrasive, because say if this is a hill and you have water running down the hill, gravity is causing the water to move faster, and as it moves faster and faster and faster, it becomes more and more of a force that is abrasive and rubs against the rocks to round them out and make them smooth. Okay, our third type of mechanical weathering, we've had ice wedging, mechanical weathering, ice wedging, abrasion, sorry. And then our third type is exfoliation. And exfoliation is just the peeling away of a rock layer. So a picture of this we saw from the USGS. I'll show it to you again. There are in this picture, you can see distinct pieces of rock, right? These little like layers. That's where the rocks have just peeled in layers and become separate chunks. This is due to if you have in a sedimentary rock, or even a non-sedimentary rock, just if you have weathering forces acting on a top layer of rock here. So my blue will be my top layer. And my red is my second layer underneath. So I have two different layers of rock here. As weathering happens and comes and weathers and then erodes away this top layer of rock, suddenly the pressure that was previously pushing down because of that blue layer of rock, right? There was that weight and that pressure from that layer. Now that it's gone, so this pressure is gone, this layer here is just going to kind of crack and separate from the bottom. So it's the peeling away of a rock layer due to the removal of pressure. Alright, and then our fourth type of mechanical weathering is animal actions. Animal actions are things like a little worm friend burrowing through the ground, rubbing against the rocks, causing the rocks to split. So you have one big rock that's kind of maybe got a crack here. Our little worm friend can break the rock. The fifth kind, or other animals, not just worms, could be rabbits, any sort of burrowing animal can cause weathering to rocks. Our fifth kind of mechanical weathering is root growth. So that just means it has to do with plant growth. If you have a tree, its roots are very, very strong. Actually, any plant's roots are very, very strong, but like a tree would be even stronger. You've probably seen before how sidewalk can sometimes be cracked because of, say, a root coming up. So you end up with cracks in your sidewalk. Your sidewalk no longer is level. Right, so there's that little spot where you can trip on your sidewalk because there's a root coming up and pushing on the sidewalk there. Roots are very strong. They can break rock. They can weather rock in that way. Alright, so then besides mechanical weathering, there is chemical weathering. And chemical weathering is The breakdown of rock by chemical means. So chemical means, for example, would be in the water. You can have acid rain due to pollution or volcanoes. You have other chemicals that get in the groundwater. That erode rocks underground. So that would be acid rain would weather rocks on the surface, and affect bedrock as it sinks down. Groundwater is going to affect bedrock and can form underground caverns. For example, we talked about like Carlsbad Cavern. This is a picture from the USGS of a cavern underground. So different types of chemicals, as they interact with the different types of minerals and chemicals in the rock, lead to the formation of really, really neat caverns underground. Alright, besides weathering, one more point about weathering. I just want you to remember that from our experiment in class with sandstone, we showed abrasion, right? As we shook our container of rocks, right, we had all our little sandstone rocks in here, and we shook it back and forth, and as we did that, and it was full of water, right, and the water makes a difference, we talked about, as we did that, these rocks rounded out, right? They started as really jagged edges, and by the time we had done 700 shakes, they were smaller pieces, and they were very round on the edges. You see all of these. So they'd smoothed out some. And the water played a role in that as a chemical weathering agent, and as just a force that was abrasive. If you also recall, the water even turned orange because it got sand in the water, so it turned this kind of brownish orange as we shook it, and that was just showing the signs of abrasion. Okay, now moving on. Beyond weathering and mechanical and chemical weathering, we also talked about soil and bedrock. And so some of the key points here: soil is just a mixture of, let's see, where's my definition? A mixture of minerals, organic material, water, and air. So you've got going minerals from rocks, so think rocks, organic material, think dead plants or decomposing plants or animals, and then water and air. So rocks break down into soil, and the rocks that break down into soil are called parent rocks. So a certain soil is going to match a certain parent rock in terms of its chemical composition. As there's two different types of rock. So you have bedrock here, and some other bedrock over here. Okay, this is location A, and this is location B. On top of the rock, you have the soil that's been formed from the weathered bedrock. So as this bedrock weathers, it's going to help contribute to the formation of soil. So the soil that lays right on top of it is called residual soil. It is residing or living, staying where it was formed. However, if weathering should happen, and then erosion. If erosion of the soil happens, this soil can be transported and come over to location B, where it is now called transported soil. So while the soil was residual soil, it chemically matched the bedrock that it was on, because that's where it came from. But when it's transported soil, it is going to be a different chemical composition than the bedrock beneath it. That's how we're able to tell that that's not its original location. That soil came from somewhere else. That means it eroded, it moved, it was transported from another location. Okay, so there's a couple different properties of soil. We'll go over really quick. Properties of soil. The first is soil composition. Composition, think something's made up of it. If something is composed, then it's formed. So soil composition, you're kind of asking the question, what kinds and how much of different materials are making up this soil? Okay, what kinds and how much, and that affects what kinds of plants are going to grow there, because different kinds of plants like different amounts of the different materials. Some plants want more organic material, some plants want less. They're all going to have a little bit, but different places have different amounts. That's soil composition. Second property of soil is soil texture. Soil texture is asking the question, how much of the different sizes of soil particles does this soil contain? So how much of a given size particle are in the soil? That affects the consistency, so how easily it can be broken up. So there's this triangle that Jill just draw that has clay, sand, and silt at the different corners. So every different soil is going to have some different texture of these different types of materials. So based on, say, I'm over here, I have a little bit of sand, a little bit of clay, but not a whole lot of silt. If I had more silt, I would be over in this corner. So the different ways they classify soil are based on where does, in terms of amounts, if this is broken up into chunks, where does my soil fall? Okay, these are like different categories, and you could say, this particular soil A falls into this category right in the middle. That means it's perfectly balanced of clay, sand, and silt. Or, oh, my soil is like 100% clay. It's going to be really hard to break up. It has so much clay, it's going to be hard to use like a rototiller to like shovel up and dig. So soil texture affects consistency, how easily we can dig. So farmers really care about that. Our third category is soil fertility. And soil fertility is asking the question, how much nutrients, how will plants grow here, and then how much nutrients does the soil have? If soil has a really high fertility, that means it has a lot of nutrients. That means the plants are going to grow really well there. If soil does not have good fertility, doesn't have a whole lot of nutrients, plants are going to struggle to grow there. Nutrients come from two places. They come from the parent rock. Remember, that's where we're getting minerals. And from humus, or that organic decaying material. So when plants and animals break down, they provide humus, they provide nutrients to the ground. Alright, so there are a bunch of different layers in soil, and those layers are called horizons. Think like the sun setting on the horizon. Right? It's horizontal. It's a straight line. Okay? So horizons of soil, there's several different layers. The top layer is organic material. So we have O for organic material. That's on top because that's where plants and animals, when they just die, are going to be laying, right? Unless someone buries them down under the ground, they're going to be on the top. So the organic material is on top. Underneath that, we have the A horizon. And the A horizon is called topsoil. So it's really nutrient rich because all the nutrients here in your organic material are going to be seeping down into your topsoil. So it's going to be full of nutrients. This is where you're going to be seeing the plant's roots growing. You want good, healthy topsoil. Underneath your topsoil, underneath the A layer is the E horizon. Now the E horizon is not very nutrient rich, so it's lacking in nutrients. Because they have been, the word is leached out. That means they've been removed. Water, as it goes down through the soil. If water lands on the surface, it's going to seep down into your soil. Might take a while, depending on how hard your soil is, but water comes down through the soil. And as it does that, it catches and carries with it the nutrients. Okay, so this is water taking nutrients with it. So it takes the nutrients from the organic material, brings it down into that topsoil, which is a good thing. But some of those nutrients from the topsoil that have seeped down into your E layer aren't going to be able to reside there because you're not getting enough refill from organic material when you're at the E layer. That means as the water comes through, it's leaching out, it's taking out these organic materials. Okay? So now we don't have good nutrients in our E layer, our E horizon. Underneath the E horizon, we have the B horizon. B horizon is really rich in nutrients. That's because all the nutrients from the E layer are being collected here in the B layer. Underneath the B layer, you have the C layer. And C is made of partly weathered bedrock. So it's got smaller pieces of bedrock, but it's weathered bedrock. Finally, on the bottom we have the R layer. The R horizon is bedrock. So think R for rock. So basically think of it like you have A, B, C, right? A, B, and C, and then with rock underneath it. E is an interruption. It's that interruption of the soil that's lacking in nutrients that have been leached out of it. O, it depends on if you have plants and if you have animals in a location that are decaying as to whether or not you have the organic material lying on the surface. You might not. You might just have topsoil. You're not going to have all these different layers in every different place, but this is the general outline. Okay, we also talked about climates, and climates are just the average weather in a given location. And we just compared different climates have different types of soil. So we said like in a tropical climate, you're going to have really good soil because you have lots of plants, right? Lots of plants in a tropical climate. So that means you've got lots of plants here. You're going to have lots of organic material. Okay, lots of it. So that means really rich soil. So then more plants are going to grow. It's a good cycle. This is different than, say, a desert where there's not enough water. So not enough water. So plants aren't going to grow. And if you don't have plants, then you're not going to have organic material. Okay, not enough organic material either. So that means you're not going to have nutrient-rich soil. So lacking nutrients in the soil. So it's just the cycle of there's not enough water, not enough plants can't grow there because there's no organic material. You're not going to have good soil. Without good soil, plants won't grow. So the desert has pretty poor soil quality. Finally, we mentioned temperate climates. Temperate climates or grasslands. We said think of like the Midwest in the U.S. You have, this doesn't really look like anything, you have wheat fields is what this is supposed to look like. Okay, this is a wheat field. So temperate climate or grassland, you have quick mechanical weathering because you have lots of temperature change. You have a moderate amount of rain, not too much rain that it's going to leach the nutrients out of the soil, but you do have rain. So moderate rain is good. Plants can grow, right? But you don't have leaching of nutrients. So your soil isn't going to lose the nutrients too fast, but it's enough water that your plants will grow. So when your plants grow and then they die, they provide humus, nutrients, organic material to the soil, which then allows new plants to grow because those new plants need the new soil. So it's a really good cycle. Okay, beyond just what soil is, all of this is to get to the point of that soil is really important. So we need to talk about soil conservation. Without soil, so with no soil, what would happen? Well, numerous things that are not good. For example, Um, Animals wouldn't have a home. Think of all the insects, all the little like worm friends that we have. Um, that would be just so sad if they didn't have a home. Poor sad worm. Um, with no soil to live in. Poor sad rabbits, right? They need the home of the soil. You would also have, so that's point one. Point two, plants wouldn't be able to grow. Plants need the nutrients that are provided in soil. So instead of a happy flower, we'd have a sad flower, right? It's not going to be able to grow. It's going to be lacking in nutrients. Okay, our third point is that without soil, there would be no storage for water. Or not enough storage for water. Inside the ground, inside your soil layers, you have water, right? Soil's made of water. But soil can also, or water can also be stored. It's what's called groundwater, right? There can be collections of water inside the ground. Think of a well. So there'd be no storage for water, which would lead to flash floods. If water didn't absorb into the soil quickly, we would have flash floods. We'd be in a world of hurt. My fourth point then is without soil, because plants aren't growing now, we're going to have trouble, right? As humans, we need the air and nutrients. By air, I mean the oxygen and nutrients that we get from plants. We'd have a problem breathing. We'd have us and animals that eat plants. Think of all the bread that we eat, right? All the things that are made from wheat or from sugar cane. We eat plants all the time. They're an important part of our diet. So without soil, plants won't be able to grow. Humans and animals would be in a world of hurt. Okay, so we need to talk now about soil conservation. Conservation, think back to our stewardship projects. We want to conserve, we want to not lose this valuable resource. It's really important for life on Earth. So in order to conserve it, in order to keep it safe, and not use it poorly or cause erosion of the soil, you need to take into account different farming techniques. So there can be a lot of different ways we talked about in class to farm responsibly. Because remember we talked about with the hillside, if you're planting, if you're tilling across the hillside and rain comes, it's going to go straight down. As the rain comes, or as you're watering even your plants, that soil is going to be eroded. It's going to be carried away. So now your hillside is lacking in topsoil. Plants aren't going to grow there anymore. I mentioned a couple books and how just without education, people don't realize this, they're destroying farmland. So there are some ways to farm that are responsible. There's contour planting, contour plowing, in which you're planting in across the slope of the hill, so that the rows, as the water comes down, the hill, the rows kind of act like a dam. They stop the water from going on, or stop the soil from eroding all the way down the hill. There's no-till farming. No-till farming, that means you leave the old stalks. So you had a plant, right? This is supposed to be corn. It doesn't look like corn. Forgive me. And then it withers and dies, right? So it withers and dies. It's no longer green. But instead of cutting it down, digging it out, you actually just leave the old stalk and then you plant new plants. So you have in the midst of your old stalk, you get new growth springing up. In the same location. This keeps it so that in the off season, when you aren't growing your plants, there's still like the roots of this plant holding the soil in place. And it's still providing nutrients to the soil. So no-till farming, you're leaving your old stock, reduces water runoff. You have terrace farming, where you take and you make your hillside, instead of being just one hill, you kind of cut it into a series of flat, it looks kind of like a staircase, series of flat farming areas. So I'm going to farm here, I'm going to farm up here, farm right here. So you have these different terraces that you farm on in order that it prevents erosion, because now you're not farming on a hillside. Now you don't have gravity acting against you. Now you just have a series of small flat fields. You could also do cover crops. So George Washington Carver, I mentioned, he said like plant soybeans or peanuts. This was back in the South in the early 1900s. He said plant soybeans or peanuts because different types of plants take different nutrients and provide different nutrients to the soil. So if you switch out your plants, plant a cover crop, or it's called crop rotation, change them year to year what you're planting, you're replacing the nutrients in the soil, and you're making sure that you don't run out of a certain nutrient. If you plant the same thing year after year after year, eventually, as those plants keep taking the same nutrients, that soil is going to run out of that given nutrient. Your soils now deplete of a certain type of nutrients. Your plants won't grow there anymore. So by switching them out, the crops year to year, or in the off season planting different things that replace the lacking nutrients, then your plants are able to grow. Alright, so that's it for chapter 9. You should be a pro by now. Please put a date, time, and place that you watched the video on your notes, and have a parent sign it. Alright, good luck for the test.